Hey everyone, and welcome. Today, we're diving into something that's totally fundamental to how we make things, but it's something you can't even see. We're talking about the invisible forces that literally shape the world around us. So let's get right into it.
Think about it for a second. How do you make a perfect product? When a machine is carving a super strong piece of metal, how does it know it's getting it just right? How do you get that flawless finish, that absolutely precise dimension, not just once, but thousands of times in a row?
Well, it turns out the secret is to listen to the machine. Not with your ears, of course, but with incredibly sensitive sensors. The real key, the heart of it all, is measuring that immense, invisible force happening right at the tiny tip of the cutting tool. Understanding that force? Well, that changes everything. So, here's what we've got on tap. We're going to start with why this is so incredibly important. Then we'll look at the classic tools of the trade, the dynamometers. After that, we'll get into newer stuff like embedded sensors and some really advanced methods. Then, the part I'm really excited about, how AI is completely revolutionizing the field. And finally, we'll take a peek at what's coming next. Okay, so let's kick things off with the big question. Why even bother measuring these forces in the first place? Well, because unlocking this hidden information has some huge and very visible payoffs when it comes to quality and efficiency. And we're not talking about small tweaks here. By getting an accurate read on these forces, you can make your tools last way longer. You can get that perfect, smooth surface finish on your products. You can make the whole machining process faster and more efficient. Really, this is the bedrock of what we call smart, optimized manufacturing. It's that important. All right, so how do we actually do this? Well, traditionally, it all starts with the undisputed workhorse of the industry, the dynamometer. So what is a dynamometer? Think of it like a hyper-accurate, super specialized scale. It sits right under the piece being worked on, and it uses these amazingly sensitive sensors, things like piezoelectric crystals that create a voltage when you squeeze them, or tiny strain gauges that change their electrical resistance when they get stretched. It uses these to measure force in all different directions. For decades, this was the way you did it. And this is where the real engineering magic comes in. A dynamometer has to pull off this incredible balancing act. It needs to be sensitive enough to pick up the tiniest little changes in force, but at the same time it has to be tough as nails to survive in a factory filled with vibrations, hot metal chips, and cutting fluids. It's a serious challenge. But don't think for a second that this classic technology is just sitting still. Oh no. Researchers are constantly pushing the envelope, coming up with new designs using things like complex crossbeams or advanced polymers. These next-gen models are even more sensitive, more stable, and can pick up a much wider range of vibrations, giving us a clearer picture than ever before.
Okay, but what if, instead of measuring from a distance, you could get right up close to the action? Really close. That's the whole idea behind embedded sensors. It's like giving the tool itself a kind of smart skin.
And the concept is just beautiful in its simplicity. You take a totally standard tool holder, and you integrate a tiny, paper-thin sensor directly onto it. So now instead of measuring the force on the workpiece from below, you're capturing the actual strain and flex of the tool holder itself as it's happening in real time.
So, just how accurate is this new approach? Getting that close. Well, prepare to be impressed.
Yeah, you saw that right. A recent study built one of these smart tool holders, and it could predict the cutting forces with an error rate of less than 1.5%. That's incredible. The big takeaway here is that this method isn't just more convenient, it's also ridiculously precise.
But, innovation isn't always a straight line. It's not just about making sensors smaller or more accurate. Sometimes it's about thinking completely outside the box and finding new ways to understand the force itself. And this is where things get really, really cool. Instead of trying to measure the force directly, some researchers are using cameras and light. One team built a cloud-based system that just watches the size and shape of the metal chips flying off the part to figure out the force. Others have created systems to literally watch what's happening on the tool's surface in real time. We're actually learning how to see the force, not just measure it.
Okay, so all of these amazing sensors, the dynamometers, the embedded ones, the cameras, they're all generating a mountain of data. But data by itself is just noise. And that brings us to the real game changer in all of this, the AI revolution. This is where we turn all that raw data into genuine predictive insight.
This is the relationship you have to understand. The sensors are the eyes and ears. They collect all the raw signals about vibration, force, and heat. But it's the artificial intelligence that acts as the brain. The AI sifts through all that noise to figure out what it actually means.
And this table here, it really breaks down how powerful that partnership is. You can see how different types of AI models, like convolutional neural networks, or CNNs, which are awesome at spotting patterns, can chew on all kinds of sensor data. They take in force signals, vision data, you name it, and they spit out these incredible outcomes, like being able to tell you exactly how worn out a cutting tool is.
And this is the absolute key takeaway. We are moving past just monitoring what's happening in the machine right now. The powerful combination of advanced sensors and smart AI lets us predict what's about to happen. We can now anticipate when a tool is going to fail before it actually breaks. That saves a massive amount of time, money, and material. It's a true revolution.
So where does all of this leave us? We've gone on this incredible journey, right? From these big, bulky external boxes to these tiny, intelligent sensors that are literally part of the tool itself.
All right, so let's just quickly recap the big ideas. First, measuring that invisible cutting force is absolutely critical for making high-quality parts efficiently. Second, the technology has evolved like crazy, from external to embedded. Third, AI is the key that unlocks the predictive power hidden in all that sensor data. And finally, when you put it all together, this synergy is what's paving the way for a much smarter and frankly more sustainable future for manufacturing.
Which leaves us with one final and kind of mind-blowing question to chew on. As our tools stop being just tools and start becoming our sensors, as the things we use to create can also feel and see and predict, what new possibilities does that unlock? What will we be able to build next when our machines are not just powerful, but truly deeply intelligent?